Question 4. Europium, atomic number 63, has two isotopes, europium-151 and europium-153. Complete the table to show the number of protons, neutrons, and electrons in the europium-153 3+ ion. So similar situations to the previous question. You've got an atomic number of the atomic mass of the isotope, and you can see it's a 3+ ion, which means this particle would have lost 3 electrons. So it tells you straight away in the question, europium is atomic number 63. So it's shouting at you there, this is how many protons this particle has got. So I can put 63 straight in there because the atomic number is the number of protons that the particle has. So number of electrons then, if we go for the 3+, it means it's lost 3 electrons, so therefore would have 60 electrons. And the number of neutrons is 153, take away 60, which leaves us with 90. 1 mark for the entire row being correct. Part B, atoms of europium have electrons in orbitals within the first 5 shells. The first 3 shells of europium are full. Complete the table to show the number of electrons in the following regions of a europium atom. Just memory, but make sure you're reading this carefully. Okay, one s subshell, an s subshell can hold 2 electrons. And that's the maximum that an s subshell and an s orbital can hold. 3p orbital. All right, regardless of the letter, orbitals can only hold 2 electrons. The third shell, remember this first shell 2, second shell 8, third shell is 18. So 1 mark for each row. Nice and generous on that one. Question 5, how many orbitals are occupied in a silicon atom? So it's very easy to jump in with this one and get the wrong answer. To work this one out, you've got to be thinking about your arrows in boxes, the way in which the electrons are arranged in the atoms. All right, so we think about a silicon atom. A silicon atom has got an atomic number of 14, so it's 14 electrons. If we go for an electron configuration first of all, that makes it 1s2, 2s2, 2p6, 3s2, 3p2. Here's your 14 electrons. Now imagine how these electrons arrange in the subshells, and you can do the arrows in boxes. So think about your 1s2, 2s2, 2p6, 3s2, and then your 3p subshell there. So put the arrows in. 1s, 2s, 2p, 3s, 3p, 1s2, 2s2, 2p, 1, 2, 3. Remember, we fill 1 at a time and then back. 4, 5, 6, 3s2, 3p2, 1, 2. The question asks how many orbitals are occupied. 1, 2, 3, 4, 5, 6, 7, 8. The answer is C. Question 6. Ytterbium, atomic number 70, which is a bit of a little bit. Is the first element in the periodic table to have the first 4 shells full. Important statement there. First 4 shells are full. State the number of electrons in the 4th shell. Well, if the 4th shell is full, then you know the number of electrons in the 4th shell because it's 2, 8, 18, 32. All right, look for clues in the questions, in these nice easy ones. How many orbitals are there in the 3rd shell of ytterbium? Okay, so in the 3rd shell, if you think about your 3rd shell, you can have 3s, 3p, and 3d. All right, if the 3rd shell is full, that means there's 18 electrons. 18 electrons, 2 electrons per orbital, therefore there must be 9 orbitals.